As you all know, we are under a global pandemic, and one of the major problems faced by every country and a healthcare system is the lack of ventilators to support the huge number of patients who would require those. So, I was thinking of a new project, a design project of making cheap, readily accessible, and on-site preparable ventilator which could be easily manufactured. So I have designed a design in the SolidWorks. As you can see, it is shown below. It works on the basic principle same as our piston and crankshaft reciprocating mechanism present in our cars. It consists of mainly a cylindrical part which is a hollow tube which can be made out of simple parts like PVC pipes, and these PVC pipes two ends are threaded externally, and it can be fitted to PVC pipe caps which is readily found in plumbing accessories shops. So these can and a hole can be drilled into the center of these caps to provide the movement of cylinder and the reciprocating piston and connecting rod, and the pathway through which the oxygen carrying tube can be passed through. In this cylinder you can see the cylindrical part. Inside this cylindrical part we places the airbag. The airbag is a bag which can be filled with air, and it has an opening which can be so this bag is connected to the piston surface. As the gear motion moves, it causes the connecting rod and crankshaft and everything to move accordingly, causing a reciprocating motion. As it reciprocates, the piston head moves up and down. At the uppermost position, top dead center, when it moves from bottom dead center, the lowermost position, to the uppermost position, it causes the air to be sucked in, and when it goes from top dead center to bottom dead center, the opposite occurs. The air is pushed out, high pressure air. So there will be two tubes coming in and out of these airbags, and one tube contains one-way valve which opens air into the airbag, and the other tube end contains another valve, one-way valve, which only allows air to flow from the airbag. So this reciprocating action causes air to be sucked from outside and to be delivered to the patient's lungs. This can be delivered to the patient through a tube or a mask mechanism. The pressure which you require to fill the lungs with adequate air should be calculation. The following calculation would be done during the following days. This is just a project. Don't consider it as final product. I did it based on my own researches and not feasible facts and reliable resources. I researched about it, but it is not a finished product, and I wouldn't expect anyone to make out of it. Now let me show you the working of this ventilator. So this ventilator, as you can see, let us um, make a cross section view out of it. And as you can see, the tiny pinion rotates the larger pinion. The larger pinion rotates a shaft which connects to a crank, and this crank is connected to another connecting rod, and this connecting rod is connected to a large cylindrical part, lengthy, and at the end of this cylindrical part there is the piston. So as the small pinion is connected to a DC motor, which it didn't show in this CAD file, and its rotation causes the piston to move up and down. This causes the air circulation, air coming sucked into the airbag, and air being pushed out of the airbag to the patient, causing artificial respiration.